Okay. Oh, just a little delayed. Okay, welcome back to Physical Science Online Edition. Today we're going to go over actually a couple equations for our energy unit. The two here that we're going to do triangles for are going to be our main two. Those are going to be the ones that you're actually expected to use for the test. I'm going to go over two other ones I'd kind of like you to know and understand, but we're not actually going to use to calculate stuff for the test. So if you need to watch it back through this video a little bit, if you need to get extra help from me, this is more meant as an intro video just to show you the equations and give you the triangle than to actually count as your practice or anything like that. That being said, let me jump in. So our potential energy and kinetic energy equations are both based on energy. That's why we're in the energy unit. Should kind of make sense to you just based on their name. Potential means the potential to be energy. Means the energy that could potentially be there. In this case, has to do with how high up it is due to its height, due to its gravitational potential energy. Kinetic energy, we already covered kinetic in our states of matter unit. Kinetic means moving. So you actually have to have a velocity in order to have kinetic energy. You have to be in motion. Otherwise, you have kinetic energy of 0. Because these ones look crazy, I'll kind of explain how they aren't. It looks like there's 4 variables in each one, but gravity is a known value of 9.8 meters per second and because you have a known value or a constant, that G can go with either term. It really doesn't matter how you write it. I like writing it this way. So if I have M and G paired up, I'll put those two together usually in my triangle, M and G, since G is a known constant. And then H can go by itself over on this other one. And potential energy is the odd one out. So now I have my potential energy equals mg times H, or I can have mg equals potential energy divided by H, or H equals potential energy divided by mg. Potential energy is measured in joules. Yep, snicker, whatever you have to do, laugh. It is measured in joules. It's spelled Joules. Not how the other thing that you were probably thinking of was spelled. I already told you gravity is a constant. Mass is measured in kilograms. And height will be measured in meters. Next one, kind of the same thing, kinetic energy. We have a constant out front here, kinetic energy equation. We have a constant. Basically, how we like you to think about this is to see that mass is less important, half of your mass. So we're going to pair up mass with the 1/2, m. And velocity is your bigger factor in kinetic energy. That's why it gets squared. V squared goes over to the side. And then kinetic energy up here. So 1/2 mass is going to be kinetic energy divided by velocity squared. Velocity squared, that's the key one. When you solve for velocity squared to find v, you'd have to do the square root. We'll practice that. So there's one extra step in the kinetic energy equation. If you're solving for v squared, it's going to be ke divided by 1/2 mass. And kinetic energy, of course, equals 1/2 mass times v squared. V measured in meters per second, mass measured in kilograms, and kinetic energy, once again, measured in joules. Those are our two equations that you have to know. The kinetic energy one has one tricky one where if you solve for v squared, you have to remember to square root it to get v. So there's one extra step in the kinetic energy equation. Then with my last minute here, because these are only 5-minute videos, just quickly talk about power and work. Once again, you don't actually need to do these for the test, but I do like you to know about them. Work refers to how far we move go with a force. So that's why work is equal to force times distance. Work is also measured in joules. So the kinetic energy and potential energy and work all kind of work together. Ha ha, pun intended. And then how you actually take that as your joules, your energy that you use, you divide it by time, and that's how we get power measured in watts. So how much time it takes you to do that is the important factor. We'll be using this concept in a really cool lab later this unit to see if we can extend or shorten the time in order to get different powers to happen. That's what I got for you. My time is just about up, so thanks for watching.